Hello everyone, my name is Jared, and today I will show you how to do this Physics 260 problem. This is number 3 from the final of fall 2009. What mass, ms, of steam, initially at temperature Ti, is needed to raise the temperature of a mass mw of water in equilibrium with its glass container of mass mgl, both at temperature T bar to a final temperature Tf is less than 100 degrees Celsius? So the best way to do this is to break down each of the parts given to us. So let's look at part A first. Now, in words, state the above heat transfer problem. So if we look at the solution, in order to raise the temperature of water, you need to add steam to it. So adding steam to it will add heat to the whole system, but the system must be trapped in the glass container so that the heat does not escape. So we want to keep it as a closed system, because if the heat escapes, then there's nothing to warm the water up. It will simply be the same temperature if all the heat escapes. So if we trap the steam inside the glass container, usually with just a lid is fine. The waters in containers' temperatures will both rise since heat is added to them. But since heat is added to the water and container, that means the steam must be losing heat, so it decreases in temperature. So given what the problem says, the steam will condense to liquid water before it loses more heat to reach some temperature where it is less than 100 degrees Celsius. Okay, that's part A covered. So part B, list the 3 steps by which the steam loses heat. Express these steps mathematically. So this is what we talked about earlier. We know that the steam starts off at some temperature Ti. It cools to 100 degrees Celsius and condenses into water. And then it says that Tf is less than 100 degrees Celsius. So that must mean the water cools down even more before it reaches equilibrium. So first, when steam cools to 100 degrees Celsius, we can use our Q is equal to mcat equation. And then we have to use the mass of steam and the specific heat constant of steam. And with our initial temperature of Ti minus our final temperature of 100 degrees Celsius, this is equal to Q1. And when steam condenses into water, Q2 is going to be equal to the mass of the steam times the heat of transformation of steam. So this is when the steam actually turns into the water. And then when this water cools to less than 100 degrees Celsius, Q3 is going to be equal to the mass of the steam, which was previously steam, but now it's water. Then the constant, the specific heat constant of water this time, now that's changed states, times the change in T. And this time, 100 degrees Celsius will be our starting temperature, and it will reach some final temperature Tf. So that's our Q1, Q2, and Q3 expressions. And part C, express the heat gained by the water and glass mathematically. So as the steam loses heat and turns into water, the cup and the original water gain heat. So we can write that the sum of the heat gained is equal to the 2 MCAT equations of each component. We know that the mass of the water times the specific heat constant of the water times its final temperature, the equilibrium temperature, minus the starting temperature T bar, and plus the mass of the glass container times the specific heat constant of the glass container times the same temperature expression used for water, since they both start and end at the same temperatures, is going to be Tf minus T bar is equal to this expression. That will be our summation of heat gained. Thank you.